Welcome back, students. In the last part, I told you about the structural representation in planar geometry. Now here, I'll be dealing with all the three dimensions, that is my x, y and z coordinates. And we'll solve that how do I represent a tetrahedral molecule in different planes, Stay tuned with me for that. So now guys, we'll be learning the three-dimensional representation of the organic compounds. The thing which I was telling you about the wedge and dash formula, okay, we'll learn now here. Also, we'll see some of the benzenoid compounds. So here we go. So this is a 3D structure and can be represented on a paper by a convention of what? If you use this solid wedge, okay, this indicates that it is projecting out of the plane of the paper. Like suppose this is my plane of the paper. So this bond which is projecting out of the plane of the paper, that is represented by a solid wedge, okay, solid wedge. And the one which is dashed wedge, okay, that is to depict that it is projecting out of the paper but downward, away from the observer. Okay, this is towards the observer, I am observing it, okay, and this is down the observer. And this one is down the observer, okay, like this way, if you can see. So this is how I represent my 3D structure of the organic compounds. I first of all take account that what hybridization is present there, okay, and according to it, in what planes the bonds can be there, and then I represent them, okay, by my solid and the dashed wedge formulas. And obviously the bond which are lying in the plane, they are just by the bond, covalent bond, simple dash. So here you can see I have drawn the structure of CH4. So if I consider this methane, okay, so these two hydrogen bonds, okay, CH bonds, C and H bond, they are in the plane of the paper. That's why I represent just by a dash, And if I look up this and this, then this one which I represented by the solid wedge, that is towards the observer, that is like this way, right, that is like this way. And the one which is the dashed way, okay, this one, so that is away from the observer in this way. So two are on this plane, okay, one above this plane and one below this plane. So that is how my CH4 structure is, tetrahedral structure, right? Hybridization, what is the hybridization of CH4? It's sp3, tetrahedral, okay? Now, here is something that how do I classify my organic compounds? How do I classify it? So, I classify like this, that either they are cyclic, okay, or the closed ring one, just like cyclopropane, cyclobutane and all, and a cyclic one, the open chain, a normal open chain. Now, even in the cyclic one, I have homocyclic or the heterocyclic, means two similar kind of cycles joined together or dissimilar cycles joined together. That is what I mean by homocyclic and the heterocyclic. Then in that homocyclic also I have alicyclic or the aromatic. And now these are the two differences, alicyclic and aromatic. Aromatic are those substances which are very sweet smelling, okay, and also possess some of the properties like Huckel's rule. Okay, there is a rule called Huckel's rule which will tell me that whether that compound is benzenoid or non-benzenoid, which is the further division there, okay. So it is a 4n plus 2 pi rule, Huckel's rule, and alicyclic is the one which do not follow that. So this is how I classify my organic compounds. So acyclic, already know that these are the open chain, okay. Aliphatic, we also say them what? Aliphatic. Like these all things. These all structures are what? These all are the aliphatic. Open chain structure. There is nothing close here. And alicyclic, okay, alicyclic one, these are the alicyclic one. Yeah? Cyclopropane, cyclohexane, cyclohexene means if there is a double bond, I said ene. If there is single bond, ane. If there is triple bond, we said ine. This is tetrahydrofuran. There is a furan structure. O in between. Then aromatic one. Aromatic one, the special types I told you, they are very sweet smelling, yeah, and all the benzene related compounds are those. So that is your benzenoid, and the other which are not following that Haeckel's rule, that is are known as non-benzenoids. So these are all the benzenoid structure. This is my benzene, okay, at first, if you look at, this is my benzene, okay. If I put NH2 there, amine group is there, right? NH2 is known as amine group. So that is called as aniline. If two benzenes are combined, homocyclic, okay, that is known as naphthalene. Then these are some of the non-benzenoid compounds, guys, non-benzenoid ones, okay, which may be cyclic one but a non-benzene, like tropolene, furan, thiophene. I like all this. Furan, thiophene, these are what? Heterocyclic aromatic compounds. They are aromatic but may be benzenoid or non-benzenoid depending upon the Haeckel's rule. There is a rule. Make it a note here. Make a note here. Haeckel's rule. Okay. So these compounds, they do not follow this Haeckel rule. And all the benzenoid compound, they follow the Haeckel rule. 4n plus 2 pi electrons it should have. That is one of the second rule is that it should be in a plane, okay, it should be planar structure. So that's all about the three-dimensional representation, guys. I hope you have fully grasped now how do I represent it in a 3D or in a plane, okay, or in a plane. So students, in this part, I told you that how do I represent any chemical molecule of organic chemistry, organic compound in three-dimensional analysis, in the 3D space, how it is generated. I also told you that how their bond rotations can be done, how their bond rotations can be done. Now in the next part, I will be teaching you about the very important topic that is called nomenclature of organic compounds. Nomenclature of organic compounds. And your IIT-JEE is already and always, it is in interest, it has shown interest in giving the questions from IUPAC nomenclature. So stay tuned with me for that.